The next problem which we have is a highly conceptual and a very important problem, because it gives us an idea of one functions, many one functions, onto functions and into functions. We have two sets A and B. The set A has 5 elements and the set B has 6 elements. We need to find total functions possible from A to B in the first part. In the second part, we need to find the injective mappings or the one functions possible from A to B. And in the third part, we need to find the number of surjective mappings, that is the onto functions from A to B. This is an easy problem, but it involves a few concepts. First, total functions possible from A to B. This is A with the elements x1, x2, x3, x4 and x5, and this is B with x1 dash, x2 dash, x3 dash, x4 dash, x5 dash and x6 dash. Now for finding out the total number of functions possible from A to B, what we need to do is, let us see the first element x1. This pre-image x1 can have any of these 6 elements as the images. So the number of pre-images possible for this pre-image x1 is 6. For this x2 is also similarly equal to 6. For this x3 is also similarly equal to 6. x4 6 and x5 6. That is, this x1 can have any one of these 6 as its image. Similarly, the element x2 can also have any one of these 6 as its image. Similarly, there are 6 options for x3, 6 options for x4 and 6 options for x5. So total number of functions is 6 into 6 into 6 into 6 into 6, which is equal to 6 power 5. So the total number of functions from A to B is 6 power 5, and this is the answer for our first part. Now for the second part, we need to find the number of injective functions, which is 1 to 1. Now let us take x1 again. For x1, there are 6 possibilities for its image: x1 dash, x2 dash, x3 dash, x4 dash, x5 dash and x6 dash. There are 6 possibilities. For x2, let us assign any one of the element of the set B to x1. Let us say we give x1 dash to x1. Now there are 4 left. Now we take the case of x2. Since x1 dash has been assigned to x1 and x1 dash cannot be assigned to now x2 because it is a 1 to 1 mapping, so there are 5 possibilities left for x2. Let us assign x2 dash to x2. Now for x3, there are only 4 possibilities left, since x1 dash has been assigned to x1 and x2 dash has been assigned to x2. So let us give x3 dash to this. For x4 similarly there are 3 and for x5 there are 2. So the number of 1 to 1 mappings from A to B is 6 into 5 into 4 into 3 into 2, which is equal to 720. Now you must be thinking that what are the number of many one mappings? The number of many one mappings plus number of one mappings is equal to number of total mappings. The number of total mappings is 6 power 5. The number of one mappings are 720. So the number of many one mappings from A to B is 6 power 5 minus 720. This 720 is the answer for our second part of number of injective functions possible. Now in the third part, we need to find the number of onto mappings or the number of surjective mappings from A to B. Now onto implies that no element of set B should be empty, or each element of set B should have at least one pre-image. Now here, even if we supply one element to each of the 5 elements of set B, there would be at least one element which would be left behind as empty, because here there are 5 elements and here there are 6 elements. Since the number of elements of set B is greater than the number of elements of set A, so there would be at least one element of set B which would remain empty, and hence the number of onto mappings will be equal to 0. Now this was a special case in which the number of elements of set B was greater than the number of elements of set A. Now let us take an example in which there are 6 elements in A and 5 elements in B. Now we need to find out the number of surjective or the onto mappings from A to B. Now we need that each of the element should be non-empty, and there are 6 elements over here and 5 over here. So let us take 5 elements from these 6 and provide 1 to each of them so that no one of them remains empty. So we select 5 from a total of 6 by 65 and then assign 1 to each of them by 5 factorial ways. Listen very carefully, this is highly important. What we need is, we need that no element of set B should remain empty for having an onto mapping. Since there are 6 elements in set A and 5 elements in set B, so we take 5 elements from set A and assign at least 1 element to the set B so that no one of them remains empty. This 65 means selection of 5 elements from a total of 6 elements, and this 5 factorial means assigning or the arrangement of this selection of 5. We are assigning the 5 elements from set A to the 5 elements of set B by 5 factorial ways. Now there is 1 element left. This 1 element can go to either this, this, this or this or this. So there are 5 possibilities for the last element left. So the last element can be supplied in 5 ways. So the number of onto mappings in this case is 65 into 5 factorial into 5. So our final answer is, for the first part, the total number of mappings possible is 6 bar 5. For the second part, the number of injective functions from A to B is 720. Many one functions is 6 bar 5 minus 720. For the third part, we had the answer equal to 0. The onto functions, number of onto functions were coming out to be 0. So the number of into functions were 6 bar 5, because the number of into functions plus number of onto functions is equal to the total number of functions. And then we took a special case in which the number of elements of set A were greater than the elements of set B, and hence in this case the number of onto functions came out to be 65 into 5 factorial into 5. So the number of into functions were 6 bar 5 minus 65 into 5 factorial into 5, and this is our final answer.